Hello and welcome to Unit 5 practice problems. In this video we're going over some graphs of derivatives and how we can differentiate graphs of f of x, the derivative f of x, and the second derivative. So it wants us to find f of x, the derivative, and second derivative of both of these graphs. And so the first thing that you see is a lot of lines. And at first it can be kind of overwhelming, but if you take it step by step, it'll kind of make more sense. So the first thing that you want to look at when you have something like this is where the maxes and mins are. So you want to choose one of the three graphs, so it can be any of them, and pretend that this graph is f of x. So we're just going to pretend it's f of x, and then if we know about the properties of the relationships of f of x, derivative of x, and second derivative, so wherever there's a max or a min on the original function, then the derivative crosses the x-axis. So if there's a max here, the derivative function should cross the x-axis, and it should be the same for here and here. As we can see, that only happens in one point, so we can't determine that this graph is the f of x function. So we got one down. And now let's go on to the next graph. So if this was our f of x graph, then right here we have a min, and then there needs to be a point somewhere there, a min again, a point somewhere there, and a max, and a point there. So this does follow the rule. So if this was f of x, then we can say this is the second, or the derivative of f of x, but there's more to it than just these points. So next we need to find where the original function increases and decreases. So right here, we can see that the graph is decreasing. And then once it gets to this point right here, the graph starts to increase. And then for the derivative graph, it's positive right here, which doesn't make sense because it should be below the x-axis, because if this is decreasing right here, then the first derivatives and the slope should be under the x-axis because it should be a negative number. So we can rule out that this is the first derivative. And if that's not the first derivative, then neither is this. And then for the third graph, if we assume that this is the original graph, then we have a max right here, and it crosses that, max right here, crosses that, or I mean a min, sorry, max right here, crosses that, a min right here, crosses that, and a max right here, and it crosses that. So all of that checks out to make this the first derivative. And now if we chose another random spot, so right here, we can see that the graph is decreasing. And then, so right here, since this is our original function, it's decreasing, or it's increasing, my bad. Increases right here, and right here is a positive number, which means that the slope is increasing, and that matches up until you get to here where it starts decreasing, and then right there the slope gets negative, and then it starts increasing here, up all the way here, and then right here the slope is positive for that whole section. So that so far checks out. And so if this is the first derivative, then this one would have to be the second derivative. And to find that out, if I erase this, oops. So wherever there's a point of inflection, then the graph of the second derivative would cross the x-axis. So like right here, it goes from concave down to concave up, somewhere over here, and then the second derivative crosses the x-axis, and then right over here, it goes from concave up to concave down somewhere over here, and it crosses over there. Over here, we have concave down, then concave up, right there, and it also crosses the x-axis at the second derivative there. So it's safe to say that that is our second derivative. So these labels right here are our answer. For the next question, it asks the same thing. This graph does look a little bit more simple. So if we speed run it, and we'll say, okay, this one is f of x, and if that's f of x, here's a max, here's a max, here's a min, nothing crosses, and that crosses, but since nothing crosses at those two maxes, this can't be the f of x. And then if we go to this purple one, then we have a max right there, and that crosses, and that's the only max we have, so this could be the first derivative. And if that's the first derivative, then where there's a change of concavity would be where the other derivative crosses. So over here, it's like concave down, but then it goes to concave up at that point, and then it crosses over there, and then same with this side, so concave up to concave down, and it crosses over there. So we can say that this is our second derivative graph. Another thing that we can check for is the increasing and decreasing on the first derivative graph. So on the original, it increases up until, increases up until here, and then it starts to decrease here until the first derivative is positive, 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 and then bam, and then it goes negative. So that also checks out. And you know that this graph right here cannot be the first derivative because it hits positive, but then it goes negative over here, which doesn't match up. So that right there is our answer, and we're done. Thank you for watching.